We're going to talk about the power rule for exponents. And we've worked with exponents already. We've talked about what happens when you multiply powers. So for example, with what I have written here, I have x squared times x to the fifth. So what we're doing here is we're multiplying powers. And what I mean by a power is something when you have a base. For example, here in the blue I have x raised to an exponent. The combination of this base and this exponent is called a power. And in the red, where I have x squared times x to the fifth, that's a power. And also x to the fifth is a power, and we're multiplying powers. Now when you multiply powers, you add the exponent. So x squared times x to the fifth simplified is x to the seventh. And that makes sense because if I went back, what's x squared mean? Well, it means x times x. It means two of them, times, and then 5 of the x's. So 1, 2, 3, 4, and 5. Need one more. So I have 7 of them then. So let me check that. 1, 2, 3, 4, 5, 6. Yep. So you have x to the 7th power. So really when we multiply powers, all we're doing when you add the exponents, it's a shortcut. Now, if I have x squared over x to the fourth, here I'm dividing powers. Now, what do you do when you divide powers? Well, when you divide powers, you simply subtract the exponents. So you always take the top minus the bottom, and in this situation, I'd have x to the negative 2. Now, if they wanted you to write x to the negative 2 with a positive exponent, remember you drop it down and it become 1 over x squared. So those are the two the main ones that we've had so far. And let's talk about this power rule for exponents. Now, in a different color here, I'm going to write down x squared and then in parentheses raised to the negative 3 power. Now, this is a little different from the two above. Notice in the first one above, I'm multiplying powers. I have a power times a power. But look at what I have in the blue down below. Here I have a power, which is x squared, raised to another exponent. This is not the same as a power times a power, because I don't have two powers that I'm multiplying down here. I have one power, and it's being raised to another exponent. So what we do here is you just multiply the exponents. So this would be x to the negative 6, because 2 times a negative 3 is a negative 6. So when you have a power raised to another exponent, you just multiply the exponents. Let's go to the first example. And before we get into this first example, let me write down another example here. If I have x squared, I'm going to erase this here, x squared raised to the third power. Now, another way to look at this, now we just went over this new rule, you multiply the exponents. All right, so it's x to the 6. Now, another way to look at this to see if that makes sense, what's it mean if you're going to cube the x squared? Well, it means you got 3 of them. So you have x squared times x squared times x squared, right? So remember, multiplication is repeated addition. So x squared times x squared times x squared, well, now you could use that multiplying power rule and you add the exponents and I get the same answer of x to the 6. So it really all means the same thing. You just got to see if your answer makes sense. So if you're taking a power to an exponent, you multiply the exponents. Now let's take a look at example 1. It says simplify. And notice I have a bunch of stuff in the parentheses. And it's all being raised to the third power. Now, everything in the parentheses is going to be taken to the third power. So that x to the negative 2 is going to be taken to that third power. Right there, the third power. And then I have a y cubed that's going to be taken to the third power. And I have a to the fourth, which is going to be taken to the third power. Now, I simplify this. So again, every one of these in the parentheses is being taken to the third power. Now, how do you take a power to an exponent? You multiply the exponents. So I have x to the negative 6, y to the 9th, and a to the 12th. Now, if they wanted you to write this with all positive exponents, I'd keep the y to the 9th in the top. I'd keep my a to the 12th in the top, but I'd drop the the x to the negative 6 down, and it becomes x to the 6, and I've written it with all positive exponents. Let's take a look at example 2. Now, the only difference between example 1 and example 2 is instead of just having something in the top, notice that I have a fraction here, or something in the bottom too. Well, it's still the same situation. I got to take everything inside these parentheses to the negative 3 power. So I have a 3 to the 0 to the negative 3 power. I have a y to the negative 2 to the negative 3 power. And I have z to the 5th to the negative 3 power. And also below, I have an x cubed to the negative 3 power. Now what I'm going to do is I'm going to simplify all that. So let's see, let's put this in a different color. So this one, let's see, 3 to the 0, power raised to an exponent, you multiply the exponent. So I have 3 to the 0, right, because 0 times the negative 3 is 0. I have a y to the 6th power, because the negative 2 times the negative 3 is positive 6. I have a z to the negative 15th power over x to the negative 9th power. Now, what's 3 to the 0 power? Well, it's 1, and anything times 1 is itself, so really I don't have that. Now, right now I probably could leave my answer like this. If they wanted me to write everything with positive exponents, I would bring the z to the negative 15th down, I'd bring the x to the negative 9th up, and I'd have x to the 9th, x to the 6th, or excuse me, y to the 6th, like that, and then over z to the 15th, since I dropped that down, and I have everything written with positive exponents. Let's do one more. I'm going to take everything in the parentheses raised to the negative 2 power. Now remember that x, that's a 1 there, isn't it? It's to the first power. So what do I have here? I have an x to the first raised to the negative 2 power. I have a y to the negative 3 raised to the negative 2 power over m to the 4th raised to the negative 2 power. Now simplify everything. So again, I'm emphasizing, before I finish this out, remember when you multiply powers, when you multiply 2 powers or more, you add the exponents. But here, when you have a power raised to an exponent, you multiply them like that. So here I'm multiplying, aren't I? So I have an x to the negative 2, y to the 6 over m to the negative 8. And you could leave it like that unless they direct you to do otherwise. How about if they wanted you to write it with all positive exponents? Well, I'd bring the m to the negative 8 up, I'd bring the x to the negative 2 down. So I'd have m to the 8th in the top, y to the 6th over x squared. And that is called the power rule for exponents. So the main thing you need to have in your notes is a real good example. Is not only the examples I gave here, but something like this, where it shows the difference with multiplying powers compared to the power rule for exponents, which was the topic here, or in other words, a power raised to an exponent.